Welcome back to Mexico News Network's Daily News, broadcasting from El Dorado Royal Spa Resort by Carisma. Remember to follow us on Facebook, Twitter, and Google Plus for more information. And visit our website, www.mexiconewsnetwork.com. Let's continue with information. As Mexico News Network covered earlier in the year, Mexican researchers developed a revolutionary method to produce electric energy from nopales, an edible species of cactus. 5 years after its development, a company has finally shown interest in this project and is currently building the first electric station in the world that will function based on this technology. The plant will be located in the magical town of Calvillo, Aguascalientes. This prototype is being constructed to provide energy for the cement production process of the Mexican company Cruz Azul, which is also the principal investor in this project. This technology is capable of providing electricity to 12,000 houses. As such, it is expected to represent an important reduction in costs to Cruz Azul. Each megawatt hour that the plant generates will be costing 50% less than the regular price stated by Mexico's Federal Electricity Commission, CFE. The construction and implementation of these eco-technologies seems to be good news for everyone involved. Mexican engineer Samuel Sandoval, an assistant professor of water resource management at the University of California, Davis campus, is helping water agencies and farmers all across California, a state with a massive agricultural industry, develop water conservation and management strategies, as well as better ways to use the water there is still available in a more efficient way. California has been facing a punishing drought in the last 4 years, which has prompted Governor Jerry Brown to decree residents and businesses to cut 25% of their current water use. However, more needs to be done, and Sandoval has a few ideas. For starters, the diversification of annual and permanent crops would be helpful in reducing the amount of water needed for crops. For instance, farmers could shift from thirsty crops to others that require less water. This would allow farmers to maintain the premium revenues from permanent crops while adding drought-tolerant crops. These changes might be tough to make, but would be together not to have any crops at all. Another proposed solution by Sandoval, it is for citizens to replace their grass on their lawns with something else that doesn't need constant water irrigation, such as gravel or cobblestone. Water shortage and droughts are becoming more common worldwide, yet simple measures like closing the tap when brushing one's teeth, or even just using 1 cup of the task, placing a bucket in the shower while the water heats up to fill it, and then fill the toilet tank for cleaning or washing the car. These choices can make a real difference. Tampons may not be the most pleasant of topics, but a team of engineers have been using this hygiene product as a literally bright solution to identifying sources of contamination in the United Kingdom's waterways. Led by environmental engineer David Lerner, a team of researchers from the University of Sheffield have provided an entirely new proposal to this sanitary accessory, using it to absorb water from streams and then study it to identify the source of contaminants. This novel method is particularly relevant in the UK, where many of England's rivers have sewage dumped into them instead of being processed at treatment plants. Lerner's team found a way to detect brighteners, a group of chemicals which is used to make whites whiter and brighter, often found in toothpaste, detergents, and shampoo. These substances glow under ultraviolet light. And how it works? Well, the team conducted a trial experiment with tampons, which lack optical brighteners. They then placed 16 tampons in different surface water outlets that curse into rivers and streams that run through the English boroughs of Sheffield. 9 of these tampons glowed after being checked under the UV light, Evidently, the examined water outlets had the optical brighteners in them. The team then placed tampons in sewers in order to isolate and determine which section of the Burroughs pipeline network pollution was entering through, thus revealing the source of contamination. Sometimes, the problem solution is easy as correcting water connections, directing the waste to the appropriate drain pipe. In other news, many regions in Mexico and other countries are beginning to experience problems related to a decline in the supply of potable water. According to the United Nations, most water consumed is used for irrigation, which means that rural areas are particularly affected as they experience lower yields in crops and livestock. A recent invention may provide a new solution. Some years ago, the U.S. Department of Agriculture created an extremely absorbent kind of starch named Super Slurper that was later used for diapers. Sergio Jesús Rico Velasco, a Mexican chemical engineer, realized that the product had a lot of potential for agriculture. Based on the formula, Rico developed what he called solid rain. It basically consists of a powder capable of absorbing massive amounts of water. The idea is to add it to plants in order to provide long-term moisture, foregoing the need of constant rain or irrigation. Only 10 grams of solid rain can absorb 1 liter of water. Once added to the soil, it is capable of maintaining a high level of moisture, which is slowly liberated to feed the plants. Rico went on to found Solid Rain, a company which has been operating in Mexico for 10 years approximately. Due to increasing concerns about water shortages, experts have performed several performance tests for the product. The results are surprising, as crops that had Solid Rain applied to the soil yielded an average of 300% more. It works by encapsulating water, providing up to 10 years of moisturizing the ground. Don't go anywhere, we'll be right back with more relevant information on Mexico and the Riviera Maya after these brief messages. Stay with us. Audio Jungle.